All right, we're going to do a carbohydrate road map. Starboard, that's us. We already did an exercise where we had to draw L-glucose. Here it is. I'm going to pick a different L sugar here. There. Guaranteed. Mirror image of the D sugar on the handout, correct? Now I'm supposed to draw a pyranose. And by the time you get to the test next week, you've done so many of these that all those steps to get to the ring, you might be able to get there without doing all the steps like written down. You're nowhere near that yet, but I'm going to help you out a little bit. And seeing as we already did a drawing of L-glucose, we've done the work. So yeah, this is the beta pyranose side right here. Up, up, down, and CH2OH down. Up, up, down, CH2OH down. Up, up, down, CH2OH down. And then we want beta N-acetal 2-amino. Well, where's carbon 2? 1, 2. 1, 2. Beta N-acetal 2-amino. What does 2-amino mean? It means replace the OH on carbon 2 with a nitrogen. Got it? That's what 2-amino means. Replace the OH on carbon 2 with a nitrogen. And it also says in this very question is there's an N-acetyl. So a little tight on space. NH and carbonyl, CH3. Please know what an acetyl is before you leave my class. Please. And a formyl. Formyl is the same except one less carbon. There's formyl. These are things you're going to see in your future anyway. What else has it got? That's it. And we want beta. What does beta mean for the anomeric? And how do you know it's a hemiacetal? Os. Beta means cis to the CH2OH. Os means hemiacetal. That's an OH. There you go. Now, what you need to know here is the Fischer aldehyde goes to carbox acid. So do it from the Fischer. And I want to point out that a hemiacetal is always in equilibrium with the Fischer, and an acetal is not. So if you have an acetal, and what do acetals end up with? Oh, I don't have the question I always have on here. Oh, well, never mind. Is there an acetal anywhere? Make a new acetal. Where's that? Oh, side. So when I make this one, I'm going to tell you what's the difference between an os and an oside in terms of this equilibrium. But I'm not ready for that. So you're going to just take the anomeric carbon, which is number 1. This is the anomeric O, I want to remind you. It's on a stereocenter that wasn't a stereocenter before. Oh. And one needs, just change this to a carboxylic acid and make sure you have the NH acetyl on carbon 2 instead of the OH, and you're done. Do it from here. Do it from there. So you got your carbonyl. Now it's an OH, but pH 9 is above 5. What happens to carboxylic acids at pH 9? Becomes an O what? O minus. Oh, I know what you did. You said O. I see what you said. 8. And I thought you said something else. And you were right. Okay, so don't forget this is an NH carbonyl CH3, and then everything else is as before. And there we go. Lithium aluminum hydride reduces carboxylic acid and amide. Yeah, to the same, well, not to the same thing, sorry. Primary alcohol now. NH ethyl. Oh. Doesn't touch alcohols. Oh, I missed this guy in the middle, didn't I? Ooh. 2 points? Yeah, because 2 reactions. Makes sense. Okay, beautiful. Next. Enzymes to make this into a 6-alpha-6-O benzylfuranus. Italicized O is like italicized N, except it's not nitrogen. It's an O. It's an oxygen. Oxygen has a benzyl group on it. You get another chance to show me benzyl versus phenyl, right? Okay. Furanose. 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 I'm going to do the furanose over here. Because to do the furanose, you're over here, CH2OH. That's not the right O anymore. Don't really need the H. This is the right O. I need this H. Put a black dot. This is for the furanose. Black dot's here. You got to rotate these chunks, the 3 chunks. It's a big chunk this time. You need the O to make a pentagon, which means it needs to go up there. That goes there. That goes there. And here's your pentagon. Didn't change that one. Didn't change that one. We got a little extra here. The chunk rotated down. That's an eraser. Yeah. I'm pretty sure it has to look like that. That piece has to match this piece, doesn't it? Sticking down has to be the same stereo center. That's a fissure. Wedges on the horizontal, bow ties, and dashes on the vertical, zippers. And what's up here is an H. And I can't remember alpha or beta, but I'm just going to copy paste. Because we got most of the work done we need. You're a little big, dude. We hope so. Yeah. Okay, so what's going on carbon 6? Where's carbon 6? 1, 2, 3, 4, 5, 6. What are you putting instead of an H? I can't erase the H. I got to white out. Oh man, this is harsh. How do we draw a benzyl, please? CH2 to a phenyl. There you go. Oh, benzyl furanose. Is it alpha or beta? And here's your group that's down. That's a carbon group, right? It's down. Alpha. Show your bio teacher this one too. Alpha means trans to that dot. So, look, biology teacher, alpha, up. Oh, no. Okay. And it's an os. So what's on this O up here, the red O? H, it's a hemi. And then I'll show you how do you know what an aldonic acid, what an alderic acid is, and a uronic acid. I'll show you those after I pause. Stop sharing. We're back. Sharing screen. I copied the handout from the biochemistry lecture area at Moodle, and here it is. Aldonic acids have the carboxylic acid on top. A alderic acid has it both on the top and the bottom. A uronic acid, I know it doesn't sound very appealing, has it only on the bottom. Okay, and these are what? Compared to the versions on top, what are these? Somebody mentioned it earlier. The deprotonated conjugate bases, yeah. Aldonate, aldarate. Oh, there's a typo. Look, what's the word supposed to be there? It's at the bottom of the screen. We found a typo. It's a urinate. I didn't want to say urinate in class, that's why. Okay. There you go, typo. Okay, so I'm going to get the Fisher aldonic acid. Guys, you have the Fisher way up here. I just want to copy this here, but make sure you got the right O-benzyl. And why does this happen? It's because hemiacetals are in equilibrium with the open form. The reaction happens through the open form. And you're going to get a carboxylic acid on top. And it doesn't say, it says acid here, so we better put OH up. Carbon 2 left. Nothing special, nothing special. Then carbon 4, nothing special. Carbon 5, nothing special. CH2O benzyl. And I think that's it, right? And we better move our notes. Uh-oh. Okay. And we're going to do 2 lactones. You ready? 2 lactones. Alpha, beta, gamma, delta, epsilon. Ooh, how do you draw an epsilon lactone when there's an ether there? Oh, step 1, H2PT. Benzyl ethers. Just a little snippet reaction. It's called hydrogenolysis. Never heard of this word. You've heard of hydrolysis? That's water cutting. What's doing the cutting here? Not water. Hydrogen, not hydro. Hydrogen. There. It's an unprotected ether, alcohol now. So benzyl ethers are protecting groups. Protecting groups. And now we're going to use for lactone. Lactone. So we're going to have carbonyl with an O, and that's on carbon 6. 6, 5, 4, 3, 2. No, that didn't work out. 6, 5, 4, 3, 2, 1. And you're right, I'm in the wrong box. I can't move my, I need to move my thing here and it won't let me. Okay, thank you. I don't know if that's one drawing, that's the problem. Control V. Carbonyl. I can't go much over today. I got an exam, guys. I'm sorry. We got OH, OH, OH. Then that's 3, and then up left again. and then CH2O. There we go. That's it. And then the delta lactone, similar story. Alpha, beta, gamma, delta, epsilon. Ooh. Alpha, beta, gamma, delta, epsilon. That's epsilon. They look the same. Oh, there's no O. There. And up, up. Down. And this had this. There. See it? Yeah. And that's a lot of stuff. And we got a boogie. And yeah. Oh, I did have it here. This reduces aldehydes and ketones, right? But there's no aldehyde or ketone. There's an O side here. 2,3-dioxypyranoside. We got the pyranos up here. This one doesn't have an N-acetyl. And carbons 2 and 3 lost their oxygens. 1, 2, 3, no oxygens. Pyran 6. And 1, 2, 3, 4 down right. 2,3-dideoxypyranoside, nitrophenol, and enzymes. It's an O side. So 1 is the anomeric O up or down based on the name alpha. Don't be a biology teacher. It's up, alpha's trans, and it's attached to a nitrophenol. Para-nitrophenol. Show all pi. He loves doing that. It's annoying, right? I just want to make sure you know how to draw a nitro group. That's the answer. And because these chemicals only reduce aldehydes or ketones, and this is not equilibrium, it's not. This is not equilibrium in this case. That's an acetal. Not in equilibrium with the open form. Older tests, I had this as like a given answer. You could actually read it if you look carefully. It was already in there, but I don't know why I got rid of it. Hemiacetals will react, acetals won't. And in this one, I want to make an acetal using the alcohols on carbons 4 and 6. Remember, acetal, what 3 things do you need to make an acetal? Every time. What 3 things do you need to make an acetal every time? Okay, I'm going to make it 4 now because you took so long. You need a catalyst. That's the 4th thing. What 3 functional groups do you need to make an acetal? Alcohol 1, alcohol 2, and aldehyde or ketone. Okay, good. Well, we have the 2 alcohol. Ketone is in acetone. How many carbons in acetone? Or butanone. Sorry, it's not acetone, it's butanone. How many carbons in butanone? 4. So how do you do an acetal? You keep the O's. You keep the O's, you get rid of the H's. You make sigma bonds to the carbonyl carbon of acetone, which is no longer a carbonyl carbon. But it's not acetone, it's butanone. The acetone is more popular. That's why I keep saying acetone. Same idea though, that's butanone now. NABH4, there's no reaction. I had that on there twice. Wow. Okay, yeah, it's not an equilibrium, there's no reduction. Oh, I forgot something. This one's correct. This one's not. I forgot there's a group that can be reduced with lithium aluminum hydride. Brandala's going to tell us what group that is. She knows 4 ways to do it. And it's in this molecule. It's green. Yeah, hey, we're out of time. There's your answer. Yeah, it doesn't reduce the aldehyde from the acetal or the hemiacetal or whatever, the Fischer. It doesn't do that. It reduces the nitro from a reaction we knew 100 years ago. Sodium borohydride won't do it. This is correct. What a day. Videos I'll try to post during the exam, 241.